Good morning, everybody.
Morning.
Yeah, so this will be the first time we're meeting on a Saturday. So, how's been your classes so far?
Very interesting. Challenging though.
Yes, interesting indeed.
Well done. So, just like what you said before, at the end of the class, you just need to practice. I think one cannot shoot. It cannot be overemphasized. You have to like practice to get better at all these things. I'm coming. I'm trying to check something. Yeah. Okay. Okay, so today, uh, did anybody practice the while loop and the for loop? Like since Thursday that we met, did you like do anything with Python?
Yeah, I'll be lying. I didn't.
I did some
Uh,
practice problems throughout the week.
oh, okay, yeah. What about Mr. Fabrice?
No, negative.
I'm not so encouraged by, yeah, I'm not so encouraged by that. Like you've been postponing it since, it's over a week now.
Since last week, yeah. Yeah.
Is it why is that so? Are you not finding it interesting or
No, I find it interesting. Very challenging too. But it's just that gotta find time to practice more. Is the scheduling that is being kind of crucial with me right now.
oh,
Yeah, but I don't know.
yeah.
There's no more excuse, to be honest with you.
All right, no problem. So I'm still working on the assignment. Hopefully after this class, I will finish it and upload to Google Classroom. So today we'll be talking about functions. And up until now, let me deal with the slide. Up until now, you've been using the inbuilt functions, like the likes of print. Which other functions have you been using?
Like the type function. Like what do you exactly mean for this?
Yeah, I asked what were the inbuilt what are the inbuilt functions we've been using before now?
Oh, yeah, like
Like
type
so
for
far.
sure.
Yeah, we have type. Which other one? Mr. Fabrice, Mr. Joseph.
We've been calling for function also from other program.
Oh yeah, that's true also. But those ones are but let's talk about I'm talking about the inbuilt functions now. Like inbuilt functions, like the ones we've been using. We've used print, we've used type. Which other ones?
Like the len function.
The len function. Awesome. We have len, which is used to check for length of a sequence. And we also have our input, which is used to get something from the user, to get input from the user. So today you'll be learning about how to write your own function. Yeah, and why that is important is because when you're writing your program, you when you're writing a real program, there's a you'll be it won't just be like 100 lines of code, and it's going to be like a huge line of code. You can have like millions, thousand lines of code, depending on how complex the project is. And when you have that, you just don't want to write them, line by line, just the way we've been writing before now. We it is always required that we make the code into some maintainable and reusable chunk of codes, which are called functions. Like for instance, let me see if I can find the file here. So what I was trying to say is the reason why we need to know how to write functions, or like why we need to know how to write functions, or we need functions in our code. Like I said, is that when you're writing your program, like when you get into the real world and you start writing programs, like real programs, your lines of code will not just be, I mean, your code will go beyond just print hello world, print your name and the likes. So you'll be having thousands lines of code. And when you have that, you just don't want them, you don't want just to be, I mean, you just don't want to be writing them line by line like this. It will not be maintainable at the end of the day. If you have to, I mean, if let's say you want to print in your program, one of the things you are doing is to, let's say, welcome someone now. Let's say you want to welcome Mr. Fabrice. You have to do print, then you say welcome, then we need their name also, right? So let's say we have something like this, welcome, then you do dot format, then the name. Let me say the name equals to Fabrice. If you are to write a program that does something like this, and let's say you are asked to now welcome 1 million people. That means you have to repeat this line of code 1 million times, right? And even with that, you have to be saying name 1, name 2, name 3, till name 1 million. So this is in this case, it's not, I mean, your code will not be maintainable. It will be so complex. And in that case, you can bring in your function. You can write function to simplify your code, and you see how this same program, how we can simplify it by using function. So to get started with, to write our function, that is sorry, please. If you want to create your function, now this is the syntax. You start with a keyword, which is called def. So please, are we following?
Yes, sir.
Yes.
Awesome. So you start with a keyword called def, which means define. And after that, you give your function a name. So like the one we want to do now, let's say we want to greet. That's the name of our function. And one thing, every rule that applies to your variable definition in Python also apply to naming your function. So don't start it with a number. It can only contain an underscore, all those rules. It also applies to naming your function. So we are calling our function greet. And after the name of your function, you put parentheses. It's very, very important. You put parentheses, and I will show you why we actually need parentheses later on. And after that, you put a colon also. How many scenarios have I shown us now that require us to use colon? Anybody wants to tell me that we've talked about in this session? How many scenarios now?
You use it when you want to do it for an if statement, like you're making a conditional statement.
Yeah, but then we've not talked about conditional statement in this class. So I'm just asking, like in this class so far, how many scenarios have we used colon now? Mr. Joseph, Mr. Fabrice. I mean, you're right, Mr. DT. You're right. I just wanted to see how far you've been following. At least we've been picking some things. Hello.
Yeah.
I asked how many scenarios have we used the colon in Python now?
How many times have we used it?
In how many scenarios, throughout from the beginning of our program, have we used colon now? This colon, this symbol.
Mhm.
Like I'm asking, where else can you remember that we used colon? Okay. Not to waste our time. We used it when we are defining our for loop. when you say for high in range of wherever, then you have to end it with a colon. And when you press enter, you always know that there should be an indentation. So similarly with with our function, when we are declining our function, after we use the def keyword, which I said means define, and we specify the name, we put parentheses, and after the parentheses, we put a colon. And of course, if you press enter, you know the next thing must be an indentation.
Correct.
So, or everything, the statements, everything that you want to, what's it called? The logic, everything you want to put in your function, every task you want your function to do, you write them in those statements, you're going to write them indented. Just like in your for loop, you know, everything you have indented is what gets repeated. Similarly with your function, when you're writing your function, every statement you have indented belongs to that function. They are the tasks that will be performed by that function. And in our case, like the task that we were asked to do to welcome 1 million people. So when you're actually creating a function, what you are doing is you are creating a template or like a blueprint. Let me call it that. You are basically creating a blueprint.
Like baseline.
Hello?
Yeah.
Okay. You said something.
No, like a baseline blueprint.
Yeah, a blueprint. Just I think the right word is even a framework now.
Okay.
Framework, blueprint. Just like you're creating like a skeleton.
A template.
Like is it a scaffold or something? I don't know. I'm using too many Englishes now. But let's just call it a blueprint. You're creating a blueprint that you can easily, you know, plug in and to generate real or what's it called? Actual elements. I believe you will understand what I'm saying now. So for our greet, we want to welcome people, right? So we say print welcome. Let's see, okay, welcome. Then let's do this. Welcome Fabrice. This is what our function does. Our function actually greets people. But right now, that's with the definition, we've defined our function like that. If there's any other thing we want our function to do, let's say we want it to print welcome Fabrice, and we also want it to do, to say we are glad to have you here. All the tasks we want our function to do, you put them, you write them and you make sure they are indented. Anything you write outside the indentation does not belong to your function. So after you've defined your function, how do you use it? That's what we call calling the function. Like the programming term is when they say call a function, they're actually telling you to use it. And how do you use it? Just like the way you've been using your type and the likes. To call your function, you just have to call the name. Like in this case, the name of our own function is greet. And after you've called the name, you put open and close parentheses. And by doing this, if we run this now, let me see. Yeah, if we run this now, you see, it says, welcome, Fabrice. We are glad to have you here. If you don't call it, it won't do anything. Like I said, this is just a blueprint. You have to use it. And how do you use it? You have to call it before it can actually give you, it can materialize. Yeah, I think that's the word. Before it can materialize, you have to call it by just calling the name and, ending it with parentheses.
And then that's the one you only run.
Sir?
That is the command you only run.
No, I run everything.
Oh,
I didn't.
okay.
I run the whole scripts and
okay.
Yeah, generate this. And one thing is, I call this once now. If you want to call it again, you can. You can call it multiple times. It's going to do whatever you ask. Whatever it is doing, the function. Like in this case, greet is. When you call the function of greet is to welcome Fabrice and say we are glad to have you here. So if we call it 1, 2, 3, 4, 5, 6. Now I'm calling it 6 times now. It's going to do that task 6 times also.
Mm-hmm.
Mm.
Awesome. So, but remember what the main task that we were asked to do. The main task we were asked to do was to welcome that we expected that we'll be given a name, and we welcome whatever name we were given. And also tell them, we've added another thing like we are glad to have you here. So how can we make it in such a way that we can what's it called? Our function can take input or can take message like your print now. When you're calling print, you have to give a message for print to you have to give a message to print to the print function to work on. So how can we also write that so that our function also takes like a message or anything? The way you do it is to pass it when you're defining your function inside your parentheses. You specify the variable you want to, the input you want your function to probably work with. In this case, we want our function to be able to say, welcome whatever name that it was, whatever name is given to it. So what we are going to do now is to just create a variable inside that parenthesis. And again, this variable here is like a placeholder. It's a placeholder. And yeah, we can say name, or let's just say first name and last name. First name, comma, last name. And once you do that, you can now use those variables you've declared inside the parentheses. You can use them inside your function now. Like in this case, we can say dot format. And we can say first name. No, let's even do this. Welcome dash dash. So first name and last name. So last name, exactly. So now we've created a function that takes arguments, or it is also called a parameterized function. This variable that I created here, they are also called they are called parameters. They are called parameters. And how do you call this function? Now that we've created a function that takes in input, that is a function that takes parameters, and those parameters are first name and last name. How do you call it? When you are calling it, you just have to follow exactly how you've defined, the same way you've defined it. You just have to call it that way. Calling it that way, you have to, if you've created your function to take arguments, you must also pass those arguments when you are calling the function. If I do this now, if I run this, it's going to raise an error. And see the error, it says name is not defined. Did you mean name 1? What am I doing? Oh, sorry. This also gets wrong. Let me run this again. The error should be coming from here, not from there. Okay, yeah, good. You see the argument, the error here. It says type error. Greet is missing 2 required positional arguments, first name and last name. So basically just telling you that you define your function to take arguments, but when you are calling it, when you want to use it, you are not passing it. And to do that, you just have to do, okay, let's say first name is Jane. And second name, last name is Fabrice. I don't know how true that is, but let's just go with that. So greet, Jane, and Fabrice. The same order as you've defined your parameters. For the first argument should be Jane, and the second one should be should correspond to the first name, and the second one should correspond to the last name. And if you call it like this, you see it says welcome Jane Fabrice. We are glad to have you here. So that's how you get to use your parameterized function, how you get to call it. And you see, I use the parameter and argument interchangeably. They are different. If you actually want to go deeper, they are different. Parameter, when you're the blueprint, the placeholder you define there, like the first name and the last name, this variable, they are called parameters. But when you are giving your function actual value for those parameters, by that time you call them arguments. That's just like the lingua franca of computer science. So as we are passing rev, as we are calling our function and we are passing the actual value now, they are meant to be called arguments. But when you're defining your function, you call them, okay, I created a function that takes in parameter. But when you are calling them and you put the actual value there, you say you've passed an argument into your function. Are we clear with that? Any question? Hello?
That makes sense to me.
Mr. Joseph, Mr. Fabrice?
Yeah.
So far, so good. So far, so good. I mean, like, what I get is like the syntax for creating function, def grid, function, then colon. Then yeah, I get that part. When you said when you're creating function, basically it's like creating a blueprint or a framework or a skeleton. So I think so far so good knowing the syntax for for creating a function. Thank you.
That's awesome. But you understand all this, right? Because we've been writing all this before now, like the use of formats with your string.
That's right.
Exactly. So I think the takeaway here is just how you can create your function, like knowing the syntax.
That's right.
Yeah. So other than that, there are two types of function. Or before I move on to that, when you're calling your function, you can make it key, you can call it there's what we call keyword argument rather. When you're calling your argument, or when you want to pass your argument, you can make them keyworded. Keyworded in the sense that you can put the what was it called? The placeholder you defined when you were creating your function. You can also call them, that was what I was practicing before we started class. You can also call them like this to make your program more readable, so that you know, okay, this is what I'm passing Jane to first name. I'm also passing Fabrice to last name. You can call them like this. This variable or this the parameter, I don't know what's wrong with me. This parameter must be the same thing must be exactly the name you put in when you're defining your function. So you don't want to say first name here and you now say F underscore name equals to Jane. It's not going to work. It must be exactly, like I said, this is just a blueprint. I just want to now, you now want to be passing actual value into your blueprint. So you must be calling the exact parameter you use there. So we are saying, like, from my blueprint, let first name now takes this actual value, that is Jane. And let last name also take this actual value, Fabrice. And when you call your function, it's still going to work. And when you are passing, one advantage of passing it like this, having to know, assigning values to your placeholder that you've defined in your function. One advantage of it is that when you are doing it like this, then you can, the order in which you pass it won't really matter. Yeah. The order in which you are passing it will not really matter like that. So if you run this again, you see, it still takes, we still have first name coming first, which is Jane, and we have Fabrice coming as the second parameter. As the second value here. So that's the main advantage of making it keyworded when you are calling your argument. You can call it in whatever order you wish. So far, you are calling them. You are using you are calling them as a keyworded argument. If you are not calling them as a keyworded argument, you have to follow the order in which you have created the blueprint. That is the order in which you have created a parameter in the blueprint. Like this. If you want Fabrice to be first name, that means you are calling this first. If you want Jane to be the last name, then you should be calling it secondly. Is that clear? Do we get that point?
Yes, sir.
All right. So also, there are two types of function. Let me call it that way. There are functions that just perform a task. They just perform a task. And there's another function that returns a value or returns like result of whatever has been done. You understand what I mean by that soon. Right? With this example that we've created now, this function only just does a task. It only does a task, and the task is to just greet, to say welcome certain people. I mean, welcome whatever name you give to it, and welcome, and say we are glad to have you here. That's the work of this one. It is not really returning anything. That is when let me do this. If you put this function inside your print, you see something like this. You see this none is going to come up. I mean, the function has done the work it's supposed to do, that is welcome Fabrice, but you see one additional output, which means none. And what this is telling us is that our function does not return any value. By return, let me create another function. Let's call it let me use the example I was doing the other time, increment. Oh, okay, let me do this. Create full name. We are creating a function called create full name. And when you're doing that, you have to pass the first name. It takes the first name as an argument and last name as the second argument. So using the first name and last name is going to create a first name for us. The function of this, the function of this function is to give us a full name that we can use in our other parts of our code. So if I just do this, let's say full name. So full name, you agree that full name is just going to be first underscore name plus space plus last underscore name. And we can print full name. So let's call full name, create full name. My first name is Gideon. My second name is, this is my second name. If we run this now, remember what I was trying to explain is parameters that, function. I'm trying to explain functions that just does a task that is asked to do, that doesn't return anything, and a function that returns something. So I want to show you how, when a function returns something, how it looks like. So when I run this, we have Gideon and Nwoye. It has, what's it called? It shows us, the function shows us the full name. But what if we want to be able to store the full name into a variable? Like we want to be, whatever the output of this function is, we want to use it later on in our code. It is not possible by just printing it out. What printing does is to just, output it to the console, output it like this, like make it obvious. show it to us. That's what print does. But what if we want to, whatever this output, or at least the result of what this function does, we want to be able to get it outside the function. Like we want the function to pass, we want to be able to store it into a variable. Then this variable must be, we must return that result. That thing that we want to take away from the result that we want to be used later on in our code, we must be able to return it. And to do that, we use this keyword called return. It's also going to be indented. Let's see, have our prints here. So return, after you write return, this is how it goes. There's no, it's not going to change anytime or anything. So if you want to return something, you write return and you say whatever, and you put a space, then you write what you want to return. Like in this case, we want to return the full name. Before now, if we do this, before I specify my return, if we do this, let's say we write my full name equals to, we are assigning whatever this function does, we are assigning it to a variable. If we run this and I print my full name, again, it's going to give me none. You see, it's going to give me none. Reason because I'm not asking this function to return anything. And one thing is, I think I should also chip this in. Every variable or anything you write inside your function it has a limited scope. This full name variable that I declared in this variable now, I cannot call it outside. If I do print full name, you see it's already underlined. So anything you use inside all the blocks of any block of code or any statements you write inside your function, you have indented inside your function like this, they are limited inside, they are limited to that, they are restricted to just within the function. You cannot use them outside that function. You can't even call it, even raise an error to tell you it is not defined. So if you have a variable here, there's what we call global variable and local variable. If you define it, let's say we have a variable here called you can say my name. We say my name, Joseph. If you have my name here, this my name here has it has what we call a global scope. In the sense that you can call it, you can use it inside, even though it's not advisable, but then you can call it inside your function and it's going to work. But whatever you define inside your function, you cannot call it outside that function. It's not going to work. So please take note of that. It's very, very important. And we say about them that they have a local scope. That is, any variable you define inside your function has a local scope, whereas any variable you define outside your function has a global scope. You can use that variable throughout all your program. Like this one now, you can use it throughout your program. But this full name that we've defined inside our variable, inside our function, we cannot use it elsewhere. Or even if okay, let me know in case you find that confusing, let me not do that. Yeah, so back to function that returns something and one that doesn't return anything. You see, when I run this, it says none. It's printed none. When I print my full name, it printed none. If I put this return full name and we save, let me put this return full name, and of course, I'm calling my function again and I'm assigning whatever it is returning, I'm assigning it to my full name. If I do this now, if I run this, you see, we have Gideon and Ayenwoye 2 times. The first Gideon and Ayenwoye coming from the fact that inside our function, we are printing the full name. And the second Gideon and Ayenwoye that you have here is coming as a result of this print statement here, print my full name. My full name coming from calling our function. So that is how you write a function that returns something. And this my full name now, we can go on to now use it in, continue using it in our, we can now continue using it in our main, outside our function, that is in our main code. So we can say print welcome, yeah, let's just welcome my full name. So I'll say welcome F and my full name. So if I run this, you see, the first Gideon and is coming from inside the function, and the second, this welcome Gideon and is coming from using the variable where we are storing what our function returns. So that is just how that. So basically, you can just see it as a way that one way like I said, whatever variable you define inside your function is only limited to that function. But having this return keyword gives you the freedom, or gives you the opportunity to take out what is it called? To make that local variable, to make it global. Not just variable, but the value of that variable, to make the value of that variable global. If you want to be able to access the value that this full name is holding outside the function, then you have to return it. And of course, return is what actually shows shows the end of your function. Once you have return full name, any other thing you write outside, it's not even going to allow you, by default. The indented, there's no longer indentation. It's not indented again. Your cursor is starting from the leftmost part. So return always, when you have your return specifies the boundary of your function. That is the end of your function. You cannot write any more statement or any more logic outside your function. Like this, outside your return statement. So return is always the last thing you put in your function. If your function is to return anything, it is the last thing you write in your function. Any other thing you put like this one, if I put, let's just say 1, you see, it's not even seeing it. See, print 1 is not coming. So any other thing you write out, any other indented statement or block of code that you write after your return will not be valid. If there's any logic you need to write or any statement you need to write, you must write them before you return. After you return, that's the end of your function. Any question before we continue? Hello?
No, no question for me.
Questions from me either.
So far, so good. Thank you.
All right. So back to our slide. Yeah, these are just everything I've explained. To define your function, you have the def keyword, which I said means define. And you have, after that, you specify your name, open and close parentheses, and inside your parentheses is where you pass your parameters, or you put like the placeholder for your argument. And after that, you put a colon, and every statement you want to encapsulate inside your function, you have them indented. And to return a value like I demonstrated here, if you want to be able to use the results of your function, if your function, your function does it, perform a task, right? If you want, let's say it's if the end of your function is to maybe like we have it here now, this particular function, what it does is to concatenate two names together and give us a full name, give us a result. If you want to be able to use that result outside your function, that is when you call your function, you want to be able to use the output of that function later on in your code, you want to be able to store it in a variable, then you must return that result. So yeah, then that and also yeah, so to also see to see why the importance of having our function. So like I said the other time that when your function is like a blueprint, is a blueprint that you just give actual value, you give that you call to materialize. So in this case now, we have we are passing Gideon and Anyawoye to our function to do. If you want to use them on another person's name, let's say we want to call, we want to generate full name for Mr. Fabrice now. Instead of having to do this thing, instead of having to write this, these are the 2 lines of code that does the logic. But instead of having to write these 2 lines of having to repeat these 2 lines of code, you can easily just, anytime you want to, create a full name, you can easily just call the function, pass your first name, we say Jean, and second name, we say Fabrice. So let me now assign it to any variable and call it now. So you can see we have the first one here giving us Gideon and Anyawoye, the second one giving us Jean Fabrice. If we need to do it for Mr. Joseph also, we just need to call the function again. Like I said, the function is a blueprint. If it takes parameter, then you give that parameter to it to materialize what was it called based on the input you've given to it. So for Mr. Joseph now, I think I remember your surname. So you just have to pass Joseph, and we'll say Kabwe. You see? If we are not doing this, what we would have done is to say we have to be calling these 2 commands. Like we've called the function 3 times now, right?
Mm-hmm.
If we had not created our function, this is how we would have been doing it. We'll call full name equals to, we even need to declare first name and last name. You can say f name 1. Then we say Gideon and Anyawoye. Then we also have L underscore name 1 for last name. We'll define that. So we'll be repeating, if we are to write, we didn't create a function, we'll be repeating this line of code, these 4 lines of code, we'll be repeating it 3 times, which is going to take a lot of space. And like I said the other time, when you're writing a real program, you're going to be having like 1,000 lines of code. So let's say you are, instead of not having to write that 1,000 lines of code, you can simplify them into reusable piece of code like we did in our function now. That is, whatever logic you think will be repeated, make them into a function, and instead of having to write those blocks of code again and again, just whenever you need to repeat them, just call the name of that function, and you pass whatever argument you think is needed for that function to work. You pass it inside, and your code is simplified and it's even more maintainable. If you need to add any logic to it now, you don't need to start changing it from every block of code that you have to repeat. You just go into the function. Let's say we also want to do something here. We want to like we are glad to have you here. We also want to include we are glad to have you here. If you had not created our function, we'll have to add another print statement here. Add another print statement here and add another print statement here. But with our function, we just need to put it inside our scaffold, inside the blueprint that we've created. And we'll put it there. Call our functions again, and we'll see. Gideon and Anyawoye, we are glad to have you here. Jean Fabrice, we are glad to have you here. Joseph Kabwe, we are glad to have you here. Very simple. So that's one of the advantages of using your function. I think this is the last thing on the, we've talked about return also. Yeah, also, I think I should also point it out that by default, the other time when I wasn't returning anything, and I called create full name, when I call create full name and I assign it to a variable, it returns none. So the thing is, by default, so when you read some textbook, they will tell you that all Python functions return something, either none or an actual value. So by default, Python functions return none. That is why you see that whenever when you assign, when I say my full name, And when I say print my full name, what you have is, you see, that's why you have this none. So by default, Python returns none like this. This is what every function returns by default. It is now left to you to, if you want your function to return an actual value, then you just have to, put whatever variable you want to return or whatever value you want to return. But having this thing, return none is same thing as not having it at all. So if you don't have it there, it's going to return none. That is another thing we need to take note of. Yeah, I think that's all for this slide. I wouldn't want us to go to the next slide. That is the conditional statement, because I want us to, I'll create this. I want us to like work on, I'll give us an assignment on this particular slide, and once we work on it and we're sure that we've understood at least to a reasonable extent, then we can start with conditional statement also. So any questions so far? Still have like 30 minutes. Any question? If you want me to go over it again or anything, please.
No
You
questions
say-
from me.
You say we still have 30 minutes?
Yeah, yes, sir.
Okay. Hmm.
Any question? Don't feel shy. It's, anything. There's no silly question. There's no. I'm trying to look at, okay. Create functions, call functions, and pass argument. Okay. I think we've demonstrated that. Okay, I think also one thing, another thing that is also worth knowing is that there's a way you can create your function to have default value. Like I said, remember I said, oh, like this first name that we have here now, first name that we have here, I said the first name and the parameters rather, I call them placeholders. So you can also write a function to have you can create your parameters with default value. Yeah, you can create your parameters with default values. And how do you do that? When you're creating your scaffold, that is your blueprint, and you're specifying your parameters, just assign a default value to it. Like let's say I want everybody's last name to be let's just say Jesus. Let me rewrite this. I want everybody's last name to be Jesus. That's like Jesus being the default value. Then we just have to write it like this. And when we are calling our function, we don't necessarily need to pass that second argument, which is the argument that has been defaulted. We don't necessarily need to call them. If we run this now, you see we should have something like, okay, you see Gideon Jesus, we are glad to have you here. If you change it to Fabrice, let me stop this since we are not returning anything, so we don't have to assign it to a variable. If I do this, you see we have Fabrice Jesus. We are glad to have you here. And if I want to overwrite the default value, then you need to that's when you need to now specify the last name. You can now call it okay, Jane now. You can say Jane. And it will overwrite what you already have. It overwrites this Jesus. Yeah, see, we have Fabrice Jane. We are glad to have you here. Any question? If there's no question, can you give me like an example of a function we can write? Like, can you think of one function we can write and let's write it together?
How about a function to check if a number is odd?
Okay. With that would be, are we going beyond what we've talked about? But okay, let's do that. Let's do that because we'll be using a conditional statement. But that can be like a great introduction to conditional statement also. So to write a function that would, we want to write a function that checks if a number is odd or even. First of all, what is odd number? What are odd number? What are even number? Odd number are numbers that are not divisible by 2, right?
Yes.
Right.
Okay, they are numbers that are not divisible by 2.
Mhm.
We got that. And even numbers are numbers divisible by 2.
Mm-hmm.
We got that. So to write our function, and we said the question says we should write a function that that tells if a number. That means the function should be we should be giving passing a number to the function. Right?
Yes.
Right.
So let's define our function and let's call it the first thing is def, right? Which is define. And the name, what name should we call it?
Check odd, or maybe
Okay. Check. Okay, let's say this okay, we are not going to be checking for even. Let's just check for odd. And of course, I said the function takes should be taking an argument, which is going to be a number. So we have to put that placeholder there, saying you're taking something and it's going to be a number. And based on should I do this? Okay. Let me not do that. Let me not do that. It doesn't matter in Python though. So check name and that. So number, we want to check if number is odd or not. I remember I said the rule or the pattern to getting odd number is that they are not divisible by 2. Not divisible by 2 is same thing as saying if you try to divide the number by 2 and there's a remainder, it means what?
oh, it means it's odd.
Mr. Joseph,
Yes, sir.
if you try to divide a number by 2
Mhm.
and it gives a remainder, what does
Mhm.
that imply?
That means it's not an even number, it's an odd number.
Is an odd number. Exactly. So how can we program that? How can we program that? Forget about the conditional listing. Based on the operators you've learned so far in the mathematical operators we've talked about, how can you know if a number has a remainder or not? This is like the simplest question I can ask.
Is to check if the remainder equal to 0 or if it's different from 0.
Okay, awesome. So what operator are we going to use to check for that? What operator gives the remainder?
Division.
Division?
Yeah.
You mean let's come to, you mean if we do 4 divided by, no, 7 is an odd number. So if you do 7 divided by 2, is going to give us 0.
Gonna be 1.
It's going to give us 1.
Remainder 1.
Reminder for that one will be 1. Because
Is
7
division the operator that will give
3.
us a remainder?
Mm-hmm.
Are you sure?
Say that again?
I'm asking for the operator that gives a remainder of a division operation. We want to check for with the logic we want to write is we want to check if remainder is not 0. If remainder is not 0, that means if the remainder is not 0, that means it is an odd number, right?
Mm-hmm.
Yeah. So how can we get this remainder? What statement or what operation can we perform between two numbers that is going to give us a remainder in Python?
Is that a modulo operator? Modulo.
Exactly.
Modulo or something like that.
Yeah, exactly. You use a modulo. That's why I say like that's like the simplest thing the simplest question I can ask. So if number divided by, number modulo 2, if it is not equal to 0, and the way we do that is to say this. Print, can say, number is odd. Then let's just add like an additional distance to it, else number is even. So, Mr. Fabrice, do you understand what we did there?
Yeah, it's just now that I just recalled that you even gave us the operation thing here. Yeah.
So if you do 7 divided by 3 now, 7 modulo 3, we get 1, which is like the remainder after after you do the successful operation there. Yeah, exactly. So that was what I was asking us.
Okay.
To get the remainder, the operator is just the modulo.
Yeah.
And we try to check if the remainder, this is what returns it. When you do this operation, it's going to give you a remainder, a number. Then we are saying if that number is not equal to 0, definitely the number should be odd. But else, that is, if it is equal to or to 0, then it is an even number. That's just our function. And if you call our function, I will say check odd, and we pass, let's pass 23. First, let me close my shell. See, it says 23 is odd. If we call it again and say, and this time around, let's add 74. I believe 74 is even. You see, it says 23 is odd, 74 is even. So imagine if we had not created a function, we'll have to be repeating this line of code all the time. Each time we need to check if a number is even or odd. We have to like repeat this line of code if we had not created a function. So you see how function is now, you see how helpful functions can be. And one idea to knowing when you have to create a function or not is when you realize you're repeating some set of statements. Set that is not just one. If you see like you have like 5 lines of code or 10 lines of code that is being repeated, or you have specific tasks you're doing in your code that seems like a repetition, then it's calling for it's calling that you make it into a function. And instead of having to repeat those lines of code, you just have to call the function that you've created and you do your task. And also, I don't expect this, but then your function is not calling your function before you define it is not valid. I believe you know that one by now. So your function is only valid after you've created it. You see now, when I call check odd before line 166, it raised an error. That still boils down to the fundamental that Python runs your code from top to bottom. So if you write, though there are some little exceptions when we get to OOP, but then just know that for now, whatever code code you are writing gets run from top to the bottom. So you don't call a variable before you define it. For check code to be valid, for check code to run, you have to call it after you've defined it. So that is that. We'll talk about this in the next class by God's grace on that'll be on Tuesday. We'll talk about conditional statements. So you understand this if and how like that. But at least just you know some of these. I mean, the ones we've been you know the print statements, you know what it does, and of course also you know that this part is the creation. I mean, it's just creating the function name. This is printing number is odd. This is printing number is even. The else and if may look cumbersome, but by next class we'll understand the logic behind it. We'll understand them better. So any question? Any question?
I mean, I don't have a question per se, but for me, when I look at Python or I look at SQL, it's like I'm entering into a different dimension where the language, like for example, when Fabrice says division, right? He was using division. I was agreeing with him in terms of division, but as you have told us, like, no, we don't call it division in Python. We call it modulo or something like that. That's how I get it. But the language is like it's different. It's like a foreign language for me, which is interesting. It's like I have to continue going back to the basics. I mean, and being able to know like, okay, this is not a division, it's a modulo. You know what I mean?
Yeah, like um Joseph, let me show you something. If you allow me to share my screen real quick, I just went back to the this thing where we did the operation. Okay, and I was looking at it and I was
You can
like,
share your
yeah,
screen.
that's what it is. Because the modulo
Yeah.
just splits out just the reminder. I
Mhm.
mean, um, let me see if I can see it here. Hold on, okay. It is this course. Okay, you see here? Do you see this screen?
Yeah, yeah, I can see your screen. Is it?
Your Word documents, you're sharing
Oh,
the
okay, hold on. Okay, okay, I'm using this screen. So do you see this?
Oh, okay, yeah, right there. That's
So
right.
you see, so the modulo, which is this sign, the percentage sign, only after doing the division, it only shows the remainder.
That's right.
You see? So, but yes, you're right. When you talk about, like different languages and stuff like that. And yes, we have to still go back to the basic and try
Yeah.
to like gauge this thing, like understand the basic one, because once the foundation is now well understood, just like me, that's why I'm struggling right now because
Like for example, you're asking about where did we use a colon, and when I look at that addition sign, subtraction sign, there's a plus sign in the colon at the end. You see what I'm saying? So it's
mhm,
like for me, it's like grasping it's like every area has its own language. So sometimes
I
when
mean,
you the terminology of the words, I'm like, okay, what is he trying to say? So I kind of like stay behind and try to catch up. But I like it because you guys are posting videos as well. So that helps a lot. So when Fabrice says division, and he said, no, 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 that's like the simplest.
mhm.
Remember when you were teaching us about the modulo, I think we spent quite some minutes on the modulo. And you're drawing some sticks on it. I don't know if you remember. You're drawing 1, 2, 3, 4, then you cross it. One, two,
Yeah.
three, cross it. So when we were talking to Fabrice, then I was like, oh, that's when he said, no, 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 no. We don't, yeah, we can call it division like that, but it's a modulo. So that's how I remember. So thank you. I mean, those repetition you did with us, it helps sometimes because you recall certain things like, oh, okay, that's what happened last time. Now I get it. So
Let
thank
me stop sharing.
you. Thank you
So
very
please, I think like I said, there's no way you can just get everything by just attending class.
That's right. That's right.
It is not possible.
Mm.
I mean, I'm not going to sugarcoat that for you. You also, aside from, sometimes you even understand in the class, you understand right away as I'm explaining things to you, but maybe after a few hours, you forget everything.
Yes.
I mean, it's possible and it happens a lot. So you still have to, by yourself, go over these things. Just I mean, it's even, I mean, I believe you are all older than me. So it's like the rule of life in a way. Anything if you want to really master anything,
Yep.
you just have to like go back to it. Same thing with book. You have to, even if you attend class and you understand, you still have to go over it again.
Yes.
That's how it gets registered to the memory. So, and if you had to like be, postponing, trust me, the way we've structured these classes is that like the last class now is important for today's class. Today's class is important for
Mm.
the
Next
next
class.
class. So
Yeah.
if you had to like, compound everything, that means
Yeah.
Falling behind. You'll be falling
you'll be
into
falling behind.
reading.
Yeah, exactly.
Yeah.
So please, I know you are all adult and you're already working. I mean, I really commend you guys. But at the same time, since you've dedicated this, I think 3 months for this program,
That's right.
whatever sacrifice you can make to make sure you
Thank
meet
you.
up,
That's
Yeah.
right.
and trust me, after, it will be worth it at the end of the day. It will be worth it. I can guarantee that. So that will be the end. I will upload the assignment, and like I said, the assignment, and like I said, let's say alongside if you want to rewatch the video or practice anything, if you are solving the assignment also, it will reinforce everything we've talked about.
Okay.
Let me ask you a question. I mean, same
Okay.
thing, but I'm trying to gauge how many lesson we have now. This is the third slide
Yeah.
of lesson.
Okay, you mean like how many lessons we have left, right?
No. How many we've gone through so far? So
Uh
because I need to go back and then start from them. So I have like where it
okay,
says
just
Python
two
lesson
lessons
one,
now, I think. Or wait,
and
is
then
it
I
two?
have one where it says lesson two, and then for today's it says lesson three. Let me see. I think I downloaded that. I'm gonna have to go back to lesson 1, 2, 3, and then see everything.
I've only uploaded two slides.
Two?
Two slides. I've only uploaded two slides.
Okay.
But for those two slides, we've had, I think, going to like 9 classes or 8 classes.
Oh, okay. 9 or 8 classes. Okay.
Yeah, but we've only had two distinct. So we're actually trying to take our time on the fundamentals, because once you understand the fundamental, analysis is, in a week, you can master analysis. Like master, I mean, not really master, but then you can really get the basics of the analysis that you can work on yourself if you understand the fundamentals.
That's very
Oh,
true.
okay.
But that is why we are trying to take our
All right.
time on
All right.
learning the
So yeah,
fundamentals.
only so far is 2 lessons, but each lesson has a lot of, okay, I get it. So only two, you only did two, or you only uploaded 2 lessons. Okay. So in each one, so lesson one, we started from like foundation module, and then you did Python, you did key functions, number, operation. Okay. All right. I'm gonna have to go
And
back to
if you're stuck or anything, you can always reach out to me.
okay.
So
Okay.
In terms of videos, I think you have posted like almost like 10 videos, right?
Because there
yeah.
is there is this YouTube channel where all the videos are posted.
That's so helpful. Mm.
So that would be the
Okay.
end. I will upload the assignment, like I said.
Okay.
Oh,
Thank you.
yeah,
Thank
you're
you.
welcome.